Alright, let's get started with Lesson 9, States of Matter. There are 3 states of matter that you should be familiar with for this class: solid, liquids, and gases. Some vocabulary words that go along with states of matter: melting, freezing, and vaporization, and here are the definitions. Melting, solid to liquid state. Freezing is going from liquid to solid state. Vaporization, from the liquid to the gas state. Condensation, you're going from a gas to a liquid. Sublimation, we go directly from a solid to a gas without going through the liquid state. And deposition, we go directly from a gas to a solid without going through the liquid state. Alright, so let's kind of diagram this, these states of matter. Look at it, what they look like on a particulate level. If you remember from the demonstration that we did in class, solids, the particles in solids are very tightly packed together. And this is because they don't have a whole lot of kinetic energy, just enough kinetic energy to create vibrational motion between those particles. The electrostatic attractive forces between those particles are pretty high, so it keeps those solid particles very rigid and packed together. But as those particles begin to absorb energy and they begin to gain more and more kinetic energy, the particles then will have a little bit more freedom to move because the electrostatic attractive forces become less and less, and so we enter into the liquid state. Alright, now remember that when we go from a solid to the liquid state, as we absorb energy, that is known as melting. And as we release energy from the liquid to going to the solid state, that's freezing. Oops. Alright, freezing. Okay, good. Alright, now liquids. Once we gain more energy, kinetic energy, the particles in the liquid state, they begin to move to the gas state, and that is known, of course, as vaporization. And when particles are vaporized into the gas state, they have a lot of degree of freedom because of the great amount of kinetic energy. The electrostatic forces between those particles is almost zero. So there's tons of freedom. The particles are able to spread out over a large area. Alright, so if those gas particles begin to lose kinetic energy, then they can move back down to the liquid state, and that is known as condensation. Like so. Alright. Now, what happens when we go directly from a solid to the gas state? So if solids gain a lot of kinetic energy really quick, they have the ability to go to zero electrostatic forces between the particles into that gas state, and this is known as sublimation. Alright, very good there. And in the opposite idea, going from a gas to a solid, that's known as deposition. And of course, that would mean that we release a lot of kinetic energy really quick, and so the electrostatic forces become very strong, and we enter into the solid state. All right? So that's kind of our idea there of our drawing. All right, so let's look at a table, and let's put this all together. This table here that should go in your study guide is really important to learn. So let's look at the solid first. The idea here is, just as we've looked at, is that solids, the motion, the particles, have very little kinetic energy, which results in the particles being in fixed positions with vibrational motion. The attractive forces are strong, which results in the particles in direct contact with each other, tightly packed. So this is the particular properties, and the particular properties will result in what we call the macroscopic properties of matter. Macroscopic means large. So because of what the particulate properties are doing, the macroscopic level, what we see, is a result of what's going on with those particles. So because the motion of solids or there's not a lot of motion, but there's tightly packed particles in the solid state, strong forces, we see that the shape of a solid has a definite shape and very hard to compress, and the volume is fixed. All right. If you look at a liquid, again, the particles in a liquid have more kinetic energy than solids. The attractive forces are present but weaker than solids, and the particles are free to move a lot more. So as far as the distance goes, the particles are close together but are further apart than solid particles due to the weaker forces. Weaker forces are still strong enough to hold the particles in a fixed definite volume but not in a fixed definite shape. So therefore liquids do not have a fixed shape, somewhat compressible, but they do have a fixed or definite volume. Now gases, because they have lots of kinetic energy, which results in the particles being free to move in a random fashion, attractive forces are pretty much negligible or non-existent. The particles are very far apart from each other, and this is due to almost negligible attractive forces. So therefore gases they do not have a fixed shape, they're very compressible, and they do not have a fixed volume. They spread out and fill up their container. Okay, so these are just some highlighted points of solids, liquids, and gases that I think you should really know and understand. Alright, so that is it for this lecture video. Make sure you spend some time studying through this and preparing for the quiz that will take over this lecture video on states of matter. So this is it for now.